Okay, 3.3 linear functions. So starting off with the definition, a linear equation in two variables, x and y, is an equation that can be written in the form y equals mx plus b. So this is a linear equation, so it makes a line, in two variables, so we have two variables, x and y. Listed here, m and b are normally constants, so this could be something like y equals 5x plus 6. That would be an example of one. The graph of a linear equation is a line. I'm right here. Likewise, a linear function is a function whose graph is a non-vertical line, right? A vertical line would be a non-function. It would be a line, but it's not a function. A linear function has a constant rate of change. We're going to call that a slope, the rate of change, and can be represented by a linear equation in two variables, which is what we have written up top. A nonlinear function does not have a constant rate of change, so its graph is not a line. Example 9, does the graph represent a linear or nonlinear function? Well, we have a line right here, but then it changes and turns into a different line. So this is not linear. We could say it changes directions, changes direction. Example 10, does the table represent a linear or nonlinear function? Now it has a constant rate of change, right? That's what we said. Where did it say it? Constant rate of change. So what that means is as x increases, y increases at the same rate each time, right? So 1 to 3, that adds 2. 3 to 5, that adds 2. 5 to 7, that adds 2, right? So we've shown here in the table that every time they move x, x changes by 2, okay? On the bottom piece, 3 to 8, what is that? 8, 7, 6, 5, that adds 5. 8 to 13, that adds 5. And 13 to 18 adds 5 again. This one is okay. This is a line because the x's all change at the same rate, and the y's change at the same rate. So this is going to be, yes, it is a linear function, F-U-N-C-T-I-O-N, because constant rate of change. ROC is rate of change. Now, if this was maybe like a +3 or something for the x's, that wouldn't necessarily immediately mean that it's not a line, but we don't know how to deal with that yet. So what we're going to be looking for is we're going to be looking for the same thing, the same changes for the x's, and the same changes for the y's. A discrete domain is a set of all input values that consists of only certain numbers in an interval. And we've already dealt with this. This would be something listed like 1, 2, 3, 4. That would be a discrete domain. Discrete. It's a domain, and then the discrete part is where it's just a list. Continuous domain would be where we list it the other way. So this would be like, I don't know, negative infinity less than x less than 10, or something like that. That would be continuous because we listed an interval, right? An interval can be written like this. All right, next page. Which of the following equations represent linear functions? So what we're going to be looking for here is we're going to be looking for the y and the x, and they have to be able to be written in the form y equals mx plus b. Notice that the y and the x are on other sides of the equal sign. They're not multiplied together. And then there can be something that's added there. So this first one, let's think about this. We have 2y equals negative 3x minus 1. Well, we could divide everything by 2 to get y by itself. and we'd have y equals negative 3/2 x minus 1/2. Well, that falls in that category, so this one's yes. Next up, we have y equals 2 over x. Well, x is in the denominator, so this is no. This one you can right away say no. Our linear equation example up here, it does not have any fractions where x is in the denominator, right? This first one, it had fractions, but x was not in the denominator, right? We can't have x or y in the denominator. Next up, well, we could distribute this negative 2. We'd have negative 6x plus 2 equals y. And that needs to be rearranged a little bit, but that is the same as what we have up here, so this is going to be yes. This one here, we have x times y. You can immediately say no. It's not going to have an x times y. This one here, we have an x squared. That's not allowed either, so we can immediately say no to that one too, because we can't have that x squared. All right, so the only ones that were yes was this one and this one. Example 12, determine whether they are linear or nonlinear. Well, this one on the left here, that one is linear. This one is linear. It makes a line, right? You can't get much more simple than that. There's a line on the graph, it's linear. The second one, this is not a line, so this is going to say non-linear. Non-linear. All right, scrolling down here. Here we're adding 1 each time. The bottom we're adding 2 each time. It's constant on top and constant on bottom, so this one is linear. This one on the right, we add 3 here, 3, and 3, so it's constant on top. On the bottom, 2 to 5, we add 3. 5 to 6, we add 1. 6 to 10, we add 4. That one is not constant, right? The top stayed the same. The top added 3 each time, but the bottom was not, so this is going to be nonlinear. All right, and it looks like that's it. All right, that's that. Let me know if you have questions on the homework.